Hello, today we will be going over the USACO silver problem, milk visits. Let's take a look at the problem statement. So, it says here that Farmer John is planning to build N farms that will be connected by N-1 roads, forming a tree. So that means that all farms are reachable from each other and that there are no cycles. Each farm contains a cow whose breed is either Guernsey or Holstein. Farmer John's M friends often come to visit him. During a visit with friend I, Farmer John will walk with his friend along the unique path of roads from Farm AI to Farm BI, and it may be the case that AI equals BI. Additionally, they can try some milk from any cow along the path they walk. Since most of Farmer John's friends are also farmers, they have very strong preferences regarding milk. Some of his friends will only drink Guernsey milk, while the remainder will only drink Holstein milk. Any of Farmer John's friends will only be happy if they can drink the preferred type of milk during their visit. And important to note here that we have a subcase where n is less than or equal to 10 to the third power. But in general, n and m are going to be less than at most 10 to the fifth power, so we should keep that in mind when initially constructing our solution. Alright, now that we've understood the problem statement, let's go sketch out the sample test case. Here we have detailed our sample test case. The first 5 lines helped us build our graph. In the next 5 lines, we trace the path from the start to end node and see if the desired milk has been encountered. So if you analyze the graph, you can see that we encountered the milk in test cases 1, 3, and 4. Trace the path to figure out why. Now we get into the solution, and your first thought should be, could it just be DFS on the tree? For each query, we could DFS from A to B and check if breed C appears along the path, reset the visitor array, and then walk to refresh for every single query. Seemed right, but something was very wrong here. So why did it break? Well, each query does an O of n tree walk to find the path. So the total complexity is O of n times n. And if you remember, n and m are both 10 to the 5. So this is way too slow. And then the recursive DFS also risks stack overflow. So I need something that works and works fast. Now comes a key observation. What if we use union find? Only 2 cow breeds exist in this problem. Every path either stays one breed or must cross a breed boundary. Then we can union adjacent cows only when they share a breed, which builds connected components separated by breed change edges across the tree. The same component targets breed C, path is one breed, check if array A equals C. Different components, both breeds appear, so the answer is always yes. I think that might be it. So let's look at the code. Alright, so here is our code. We begin with the implementation for union find, disjoint set union. I will cover this in a future video, but I have attached the USACO guide explanation in the meantime. Alright, now for the actual implementation. So we start with reading in our input using the cat.io class, which as always I will link in the description. And then we begin unioning. So because only 2 breeds exist, we can union 2 cows only if they're the same breed. And essentially what's left over is a bunch of components, each one entirely one breed, split apart wherever the breed actually changes. So that's exactly what we're doing here. If our array A equals array B, meaning that they're the same type of cow, then we union them. And then we initialize a string builder because we are outputting a binary string. And then we start reading in our paths. So what's our first node, what's our ending node? And then we check if the whole path is one breed. We just check if that breed matches what we want. Otherwise, that path has to cross a breed change, meaning no matter what, they're going to be happy because both breeds are encountered. So happy will always be true in this case. Therefore, we can append 1 or 0 based on the result of happy. And that concludes our code. Let's see if it works. Alright, so I've attached our code and let's see if this works. Alright, and it looks like we are getting all test case pass really fast. So that concludes that our code works. Now let's dive into some key takeaways for this. Alright, so key takeaways from this problem. 1. Check if your approach is wrong or slow. Passing a few small cases and then failing everything else usually means that your code is really slow rather than wrong. And then using union find definitely is a good idea when there are only two distinct components. Alright, that concludes this video. Thank you so much.